Hi everyone, for today's lesson we are going to learn about proofs about lines and angles. There are two parts to this lesson. There's going to be parts where we are going to be talking about adjacent, complementary, and supplementary angles. That's considered part one. Part two is when we talk about vertical angles and linear pairs. So that is part two, with part three being where we talk about proofs of all of these vocabulary words. So the first part is going to be over adjacent, complementary, and supplementary. So we're going to call these part one. And the other ones that we have in here are two others, which are linear pairs and vertical angles. They are considered part two. Once again, with part three being proof writing over the vocabulary words that we have here. Before you get started with this video lesson, please make sure that you have watched and completed the vocab video lesson for all three parts. So in these parts, we learned about, in this lesson, we learned about adjacent angles, complementary angles, and supplementary angles. Let's go ahead and recap on those. Adjacent angles are when you have two angles that are not overlapping each other, meaning like there's not one angle inside of the other. And they have the common characteristics. Number one, they share a common vertex. That means that they both have the same corner point, or same end point, or middle point, or vertex. So they share this point together, and they share a side. And remember that sides of angles, they are rays. So an example of adjacent angles are, we have the green angle and the yellow angle. They both share a side and they both share a corner. They share that vertex. Here is another example. These two angles together add to equal a straight line, and they are adjacent angles because they share a common endpoint and they share a common side. Some examples of non-adjacent angles are like angles 1 and 2 here. They share a side, but they don't share a common vertex. Or the pink and the blue angles. They share a common vertex, but they don't share a side. Now, in this picture, there does exist there does exist adjacent angles, but these adjacent angles aren't the ones that we are talking about. So 3 and 4 are not considered adjacent angles. Instead, they're considered vertical angles, but we'll talk about that in a little bit. The next kind of angle we have is complementary, and complementary are any two angles. So all of these are talking about two angles, so only two. If you see something that has information about 3 angles, no, we're not interested in that. It's all about two angles that add to 90 degrees. So they can be both complementary and adjacent or non-adjacent. Adjacent means together these two angles form a 90-degree angle. Or non-adjacent means that they're completely separate angles that just so happen to add to equal 90 degrees as well. And finally, we have supplementary angles. And that is two angles that add to 180 degrees. And once again, they can be adjacent or they can be non-adjacent. Adjacent angles meaning that they are connected to each other, this one being 120, this one being 60, and together they add to equal a straight line. So you always want to look for a straight line when it comes to supplementary angles. They could also be non-adjacent, so just two random angles with no relationship to each other than the fact that they add to equal 180 degrees. So let's go ahead and look at the first part. In example number 1, we want to tell whether the indicated angles are adjacent to each other. So it would be very helpful if you have some color with you, so you can use like colored markers, pencils, colored pencils, pens. You're going to want to have color because that's going to really identify what angles we're talking about. So the first angle we have here is angle BAC. So here is angle BAC. AC. All right, the next angle that we have is angle CAD. So yes, these two angles would be considered adjacent to each other because they share a common vertex and they share a common side. So the answer is yes, they are adjacent. So they are adjacent angles. Let's look at letter B. For letter B, we have angle EFG, and the other angle that we have is HGF. So these two angles, they share a common side, but they do not share a common vertex. So the answer in this case is no, they do not share a vertex. So they are not adjacent. Letter C. In this one, we were going to look at JNM. So here's JNM. And L and K. So here's L and K. And in this case, no. They share a common vertex, but they do not share a side. So the answer is no, they are not adjacent. They do not share a side. All right, let's go ahead and look at example number 2. For example number 2, it says name a pair of complementary angles. So we just want to name a pair. So that means that we're talking about two angles. So name a pair of complementary angles, and a pair of supplementary angles, and a pair of adjacent angles. So there might be many answers for you to just name certain angles. So there might be a lot of answers, but you want to just kind of look at the numbers and figure out which ones add to 90 degrees, 180 degrees, and are adjacent to each other. So looking at complementary, we want to look at two angles that when added together will equal 90 degrees. So we're looking at 90 degrees. And if I were to look at the smallest angles, I have 52 degrees plus 38 degrees. And they both add to equal 90 degrees. So where do those angles come from? Well, we have angle ABD. So we're going to say angle ABD. And angle CDB. That's where 52 and 38 came from, and we're just giving them a name. Let's go ahead and look at supplementary angles. Remember that supplementary angles add to equal 180 degrees. So this might require a little bit of thinking. So we have 128 degrees. That's an obtuse angle. And let's see, would 128 plus 38, would that equal 180? Let's go ahead and check that out. 128 plus 38 degrees, that's going to be equal to, well, 166 degrees. And that's not equal to 180. So CDE would not be considered a straight line because they don't add to equal 180. So that's not the right approach. Let's go ahead and look at 128 plus 52. So I'd have 0, add the 1, 1 plus 3 is 3, 3 plus 5 is 8, 180 degrees. So the 128 degrees and the 52 degrees, that's going to be your supplementary angles. Remember, supplementary angles do not have to be adjacent to each other. They just have to add to equal 128. So where do those angles come from? Well, the 128 degrees, that was EDB. So we're going to say angle EDB and angle, let's see, we want 52 degrees, that was ABD. So I'm going to write angle ABD. Remember that whenever you name angles, it's all about whatever the corner point is. That's the letter that goes into the middle. Let's look at adjacent angles. Well, adjacent angles, remember, they share a common vertex and they share a common side. So it looks like EDB and CDB, they would be considered adjacent angles. So that's angle EDB and angle CDB. They would be considered adjacent. All right, let's go ahead and look at example number 3. For example number 3, we have angle 1 and angle 2 are complementary angles. Remember, those are the ones that add to equal 90 degrees. And we are given the measure of angle 1, and we are asked to find the measure of angle 2. So looking at the measure of angle 1 being 52 degrees, we know that the measure of angle 1 plus the measure of angle 2 would have to equal 90 degrees. So if I know that the measure of angle 1 is 52 degrees and I don't know what the measure of angle 2 is, but I do know it equals 90, this would be the equation that I would set up. So now I'm going to subtract both sides by 52, and when I do that, I'm going to end up with 38 degrees. So the measure of angle 2 is going to be equal to 38 degrees. Now you do not have to get fancy with it like this. This is how you would set up an equation to solve your answer. Or you can be a little bit more informal and just say, what is 90 minus 12? So in example letter B, we know that the measure of angle 1 is equal to 12. And all we would need to do is find their difference. 90 minus 12, that's going to be equal to 78 degrees. So the measure of angle 2 is going to be equal to 78 degrees. Both ways are perfectly appropriate for solving or for finding the measure of angle 2. Just show me how you are approaching the problem. I just wanted to make sure that you guys see the formal way as well as the informal way. Same thing is going to go with example number 4. In example number 4, we are told that angle 1 and angle 2 are supplementary angles. That means that they add to equal 180 degrees. Now here's the trick. C comes before S, 90 comes before 180. So that's the trick. C comes before S, 90 comes before 180, and that's how you remember which one is supplementary, or which one's 90 and which one's 180. So getting formal with it, we are given the measure of angle 1, and once again we want to find the measure of angle 2. So I know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees this time. The measure of angle 1 is 72 degrees. Plus, I don't know what the measure of angle 2 is, and I just know that it equals 180. So I'm going to subtract 72 on both sides, and when I do that, I'm going to end up with the measure of angle 2 is equal to, looks like that's going to be 108 degrees. So this is very formal, but you can go more informal by just taking 180 and subtracting 137. And when you do that, you're going to be left with 43 degrees. So the measure of angle 2 is equal to 43 degrees. Both ways are perfectly acceptable for showing answers. All right, let's go ahead and move on to the next page. You might be given some information about measure of angle A and measure of angle B, being told that they are supplementary or complementary. And we want to make sure that for these types of problems, we show all of our algebra work. So for this problem, what we want to do is we want to set up an equation. Now remember, supplementary means that they add to 180 degrees. So I'm going to write 7x minus 3 plus x minus 1, they equal 180 degrees. So now I'm going to combine my like terms, and I end up with 8x minus 4 is equal to 180. I'm going to add 4 to both sides, and when I do that, I end up with 8x is equal to 184. So now I'm going to go 184 divided by 8. Show my work up here, sorry. So I'm going to write 8x is equal to 184, and I'm going to divide both sides by 8. And when I do that, I end up with 23 as my answer. But I am not done because I want to find angle A and angle B. I want to find those measures of angle A and the measure of angle B. So not only do I have to find what x is equal to, I now need to go back up here and say the measure of angle A, that's equal to 7x minus 3. So that's going to be 7 times 23 minus 3. And 7 times 23 minus 3, that's equal to 158 degrees. Next, what you can do to find the measure of angle B is you can go 23 minus 1, plugging it directly into our function, or you can, or our expression for the measure of angle B. Or what you can do is go 180 minus 158, but whichever way you go about it, you're going to end up with 22 degrees as your answer. Make sure that whenever you're working with angles that you have degrees as a part of your answer. Example number 6 is very similar. We are told that angle A and angle B are complementary. So we want to find what the measure of angle A and the measure of angle B is, showing all of our algebra work. So remember, complementary means that they add to equal 90 degrees. So we're going to write 5x plus 4 plus 7x minus 10 is equal to 90 degrees this time. And we want to combine our like terms. So 5x plus 7x, that's 12x. And 6 minus 10, that's, 4 minus 10, that's going to be minus 6, is equal to 90. I'm now going to add 6 to both sides, and when I do that, I end up with 12x is equal to 96. Dividing both sides by 12, I find that x is equal to 8, which is awesome. I have x equals 8, but that's not what the question was. They want you to find what the measure of angle A and the measure of angle B is, so I have to plug 8 back in for x into both A as well as B. So the measure of angle A, that's going to be equal to 5 times 8 plus 4. So that's 40 plus 4, which is 44 degrees. Now, you can do just like I did back up here, where you can substitute this x value directly into your expression for the other variable. Or you can say that the measure of angle B is simply equal to 90 minus 44. And 90 minus 44, that's going to be equal to 46 degrees. This is one approach. Or you could go 7 times 8 minus 10. So that's 56 minus 10, which is still 46 degrees. And those are your two answers. So it just depends on how you want to approach your problem. Finally, we have example 7 and A and B. In example 7, what you want to look for is our 90-degree angle. 90-degree angles indicate that the other side is going to be 90 degrees, because that this is a whole line, ABE is a whole line, and we know that one side of it is 90 degrees. We know that 180 minus 90 is equal to 90 degrees, so the other side has to be 90. So therefore, the equation that we are going to be setting up is 2x plus 3x is equal to 90. So for this problem, we want to find the measure of angle ABD. So ABD is right here. Here's ABD. And then we want to find the measure of angle DBC. So DBC is located right here. And we want to show all of our algebra work. So before we do that, we need to find what x is. So, and we also need to look at our relationships between all of the angles. So what we've been able to see is that 2x and 3x are actually complementary angles, because they would add to equal 90 degrees. So my equation that I'm going to set up is 2x plus 3x equals 90. So 2x plus 3x, that's 5x, is equal to 90. And I'm going to divide both sides by 5, and when I do that, I'm going to end up with 18 as my answer. So x is equal to 18, but I'm not done. Please be careful. You might see this on a test. It might even be a multiple choice problem or something like that, and 18 will be one of the things that you can pick. But that's not an answer because we have to go back to the very beginning and actually answer the question. So please be very careful. So now I'm going to go find the measure of angle ABD. So ABD, remember, was the orange angle. And that was 2x. So that is 2 times 18. And 2 times 18, that's going to be equal to 36 degrees. And now we need to find the measure of angle DBC. And the measure of angle DBC, remember, that was the pink angle that I had right here. And that is 3x. So we want to go 3 times 18. And 3 times 18 is equal to 54 degrees. Next, we're going to go ahead and look at letter B. For letter B, these two angles are going to add to equal 180 degrees, and there's no symbols indicating that they were bisected, nothing like that. So what we do know is that 4x plus 6 plus 11x minus 6 is equal to 180. These two angles are supplementary angles because they are along a straight line. And if you see a straight line, that indicates that they are supplementary and would add to equal 180. So I'm going to combine my like terms. 4x plus 11x, that's equal to 15x. And 6 minus 6, they end up canceling away. And that's going to be equal to 180. So now I'm going to divide both sides by 15. And when I do that, I'm going to end up with 12. But I'm not done. Remember, I wanted to find what the measure of angle ABD is. And so here is ABD. And then I also want to find what the measure of angle DBC is. So I'm going to maintain my same colors that I did before. So the measure of angle ABD this time, that's going to be equal to 4 times 12 plus 6. So that's 48 plus 6, which is going to be equal to 54 degrees this time around. But it's not going to be 54 and 36 this time around. Remember that they are supplementary, so they add to equal 180 degrees. So you have a choice. You can either plug 12 directly into the other expression, or you can go 180 minus 54. It just depends on what you want to do. So far we have the orange angle, and now what we want to find is the measure of angle DBC, and that's my pink angle. And that's going to be 11 times 12 minus 6. So 11 times 12, I believe that that's going to be equal to 132. And then we're going to subtract 6, and that's going to be equal to 126 degrees. Or you could have simply done 180 minus 54, and that will also get you 126 degrees. Both ways will get you the exact same answer. It just depends on what you want to do. And that is the end of part 1 for this lesson over adjacent, complementary, and supplementary angles. The next video lesson will have part 2. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.